Once you see the pattern in how we talk about AI capabilities, you can't unsee it. Every time an AI crosses a milestone we said would prove real intelligence, we immediately move the goalposts. A new paper argues this game is over. The goalposts have run out of field. In 1950, Alan Turing proposed a test. Could a machine fool humans into thinking it was human through conversation alone? For 75 years, this was the benchmark. Pass the Turing test. Achieve human-level intelligence. March 2025. GPT 4.5 was judged human 73% of the time. Actual humans scored lower. But that's not even the most interesting part. Current LLMs have: you won gold at the International Math Olympiad. You solved PhD-level problems across multiple fields. You collaborated with leading mathematicians on proofs. Generated scientific hypotheses validated by experiments. Written code used by professional programmers. Yet when surveyed in March 2025, 76% of leading AI researchers said current approaches are unlikely or very unlikely to achieve AGI. How is it possible that machines passing the Turing test and solving Olympiad math problems don't have general intelligence? 4 researchers, spanning philosophy, machine learning, linguistics, and cognitive science, think the disconnect is part conceptual, ambiguous definitions, part emotional, fear of displacement, part commercial, business interests distorting assessments. Their controversial conclusion: by any reasonable standard, AGI already exists. The definitional trap. Here's where it gets fascinating. What does general intelligence actually mean? A system that can do almost all cognitive tasks that a human can do. But which human? Marie Curie couldn't prove advanced theorems. Einstein couldn't speak Mandarin. Are they not generally intelligent? The reframe. The paper argues we've been demanding that AI meet standards no individual human meets. Think about it. We credit children, average adults, and Einstein with general intelligence despite vastly different capabilities. Why should the bar for machines be superhuman across all domains? What intelligence isn't? The paper demolishes 4 common misconceptions. Perfection isn't required. No human has perfect depth even in their specialty. Darwin didn't know everything about biology. We don't expect humans to be flawless. Why do we expect AI to be? Universality isn't required. An octopus controls 8 arms independently. Insects see UV light. Humans can't do either. We don't lose our general intelligence card because we can't echolocate like bat does. Human similarity isn't required. Intelligence is a functional property. It can exist in different substrates. We'd recognize intelligent aliens even if they didn't have our cultural references or cognitive architecture. Same logic applies to machines. Superintelligence isn't required. Superintelligence, a vastly exceeding human performance across almost everything. No human meets this bar. Not Einstein, not Da Vinci, nobody. Yet we keep demanding AI reach it before we'll call it intelligent. Here's the devastating observation. When we assess human intelligence, we don't peer inside heads to verify understanding. We infer it from behavior, conversation, problem solving. We're applying one standard to humans, behavior-based, and another to AI, mechanism-based. The paper proposes 3 levels: Turing test level, basic school education, adequate conversation, simple reasoning; expert level, international competition performance, PhD level problems, multi-domain fluency; superhuman level, revolutionary discoveries, consistent superiority over all experts. Current LLMs are solidly at level 2. The science fiction test. Wild benchmark. Current LLMs show more breadth than HAL 9000 from 2001, A Space Odyssey. HAL was fiction's poster child for scary superintelligent AI. Real 2025 AI is more broadly capable than 1968's imagination of 2001 AI. Let that sink in. They're just lookup tables, solves novel problems. They're just pattern matching, proves new theorems. They don't understand, assists frontier research. Notice the pattern. The objection shapeshifts but never disappears. This echoes an 1843 objection from Ada Lovelace. Machines can never do anything really new. Turing addressed this in 1950. 183 years later, we're still making the same argument, just with different vocabulary. The 10 objections. The paper systematically addresses 10 common objections. Here are the most interesting. They're just stochastic parrots. Then explain gold medal Olympiad math on unpublished problems. They lack world models. Ask one what happens if you drop glass versus a pillow. It predicts correctly. They don't have bodies, so they can't be intelligent. Would you deny intelligence to a disembodied alien communicating by radio? A brain in a vat that answers questions perfectly? Stephen Hawking, who interacted almost entirely through text. The double standard is glaring. They lack agency. They don't form independent goals. True, but intelligence autonomy. The Oracle of Delphi only spoke when queried. Was it not intelligent? Agency matters for moral responsibility, but it's not constitutive of intelligence itself. Let's dig deeper into stochastic parrots because this objection is everywhere. The claim, LLMs just interpolate training data. They can't handle truly novel problems. But current LLMs solve unpublished math problems, perform near-optimal statistical inference on novel data, transfer learning from code to non-coding domains. Here's what keeps me up at night. There is no guarantee that human intelligence isn't itself a sophisticated version of a stochastic parrot. All intelligence, human or artificial, must extract structure from correlational data. The question is just how deep the extraction goes. I think the real reason we resist calling this AGI isn't technical. It's that admitting machines have human-level general intelligence forces us to confront uncomfortable truths about what makes us special or not. Economic displacement, the nature of consciousness, our place in the world. The paper uses inference to the best explanation, the same reasoning we use to attribute intelligence to other people. We can't read minds, we infer intelligence from behavior. An entity that passes Turing tests, solves Olympiad math, and assists frontier research. What else could explain that besides intelligence? One insight I haven't seen elsewhere. Tech companies have business incentives to keep AGI always just out of reach. AGI in contracts often triggers obligations, governance requirements, or profit sharing with investors. Admitting we already have it is expensive. The paper's most valuable contribution isn't its conclusion. It's the conceptual house cleaning, separating intelligence from perfection, distinguishing intelligence from autonomy, recognizing intelligence as functional, not substrate dependent, exposing anthropocentric biases. The authors come from different fields, philosophy, ML, linguistics, cognitive science. They initially disagreed. After extensive discussion, they reached consensus. By reasonable standards, including Turing's own, we have AGI. That convergence matters. Here's a thought experiment. Imagine an alien civilization contacts us. They communicate only through text. They solve our hardest math problems. They help design experiments. They write poetry and code. Would you deny their intelligence because you can't verify their internal understanding? If not, why apply that standard to AI? Why does this matter beyond academic debate? The paper argues recognition of facts, policy decisions, risk assessment, understanding of mind, our model of reality itself. Pretending we haven't crossed this threshold doesn't make us safer. It makes us unprepared. The most haunting implication, if we apply the same standards to AI that we apply to humans, and if AI meets those standards, then either AI has general intelligence, or the standards we use for humans were always inadequate for detecting real intelligence. Pick your poison. The paper ends with stark clarity. The long-standing problem of creating AGI has been solved. Not will be solved when not is close to being solved, has been solved. The vision Turing laid out in 1950 is, by his own standards, now reality. So if AGI is here, what changes? The paper argues, eyes unclouded by dread or hype will help us to prepare for what comes next. Not denial, not panic. Clear-eyed recognition of what we've created, what it can do, and what that means for everything that follows. Maybe the question was never, has AI achieved human-level intelligence? Maybe it's always been, can we recognize intelligence when it doesn't look like us? Turing knew in 1950 that this was the real test, not of the machines, of us.